my bachelor's and my master's there, and then I did my master's in HEI at CMU, and then I escaped to Finland. My wife is from there, and I've been there ever since. I did my PhD there, and now I lead my own research group in Finland, the Community Instrumentation and Awareness Group, and I'm now an adjunct professor at our university. I teach at the university, and there's some links in there if you want to know a little bit more about what I do, but I will be talking about that today, so for those who are here, you will get to know what I do. So if you don't know where Oulu is, so the University of Oulu is halfway to the north. So I don't know if you, does this have a pointer in there? No. Okay. So the Arctic Circle is over there where Rovaniemi is. So that's really close to where Santa's village is. We get awesome weather, sometimes minus 40 in the winter. So it's quite an experience for someone who's from here. It's a small university, it's not too old, from 58, 6 faculties, a lot of students, and we mainly focus on 4 areas: IT, biosciences and health, cultural and interaction, environment, and natural resources and materials. The good thing about the university is that we are all in the same building, and we collaborate a lot between each other, especially when it comes to multidisciplinary research. So my research group, the idea is that we would leverage technology, and this is any sorts of technology, sensing, wearables, computers, in order to improve people's lives, try to understand frustrations, and somehow fix them. This is very broad. I will give you some examples of the things we've done in the past. And so I did say this in the beginning, so I did my software engineering background here in Madeira. In the US, I did my human-computer interaction, and then I did my PhD in ubiquitous computing. So what has happened throughout this process is that my way of thinking about problems has changed. So when I was a software engineer, I would think about code first, ask the questions later. If there are bugs, I will fix them, it doesn't matter. But then when I did my HEI, it was the opposite. Talk first with people, see what they want, and then you build what they want. And then everything gets jumbled up when I started doing ubiquitous computing, because you talk with people, you do something, and then you go and deploy it, and then things don't work, and then you go back to your lab and you try to fix them again. So the thing is, also, with this transition, also what happened is that the notion of a computer has also changed. So if you think about, in the old days, you had a lot of people using one computer. You would rent a computer to use it. And then in the 80s, you start to be able to afford a computer. Everyone had their own computer, so it was more like one-to-one kind of thing. Right now we are here. So you actually have multiple devices. You have your laptop, you have your wearables, you have your computer at home, you have your computer at your office. And what we're thinking is, how do you design something in the future that is actually shared across multiple people? So your computer is not your computer, it's actually everyone's computer. So this is what ubiquitous computing is about. And this is where my research group and our research focuses a lot. In the sense that we build technology or systems that are not just for you, but for everyone. Okay. So what that means is that I can't work alone. It means that I can't just be a software engineer, I can just think about a problem from a technology perspective, but I need to talk with psychologists, with medical, sociologists, everyone, literally everyone, even architecture, in order to make the technology fit in and intertwine itself into everywhere you go. This means I need to build things like use tools that can be used and understood by multiple people. It's not just me as a coder. I know how to do an SQL query, I know how to code, but if I ask a medical, just check if you have data on from your participant. They have no idea how to do that unless I give them a tool to do that. And so a lot of the need here is, from our side, is we need to design and implement and also evaluate, reuse and share the knowledge we have as technologists and engineers, and have those as resources and results for anyone else to use. Okay? So basically, this is how my whole process has been. From the moment I graduated here as a software engineer, I could do stuff, I could build stuff, but I also had to think about how can I make what I do available to everyone else. Okay, so the biggest challenge I have is the context in which this technology is going to be used. I will give you some examples of that. So think about the context right now. So this is the process I usually follow. So I have a problem, or we identify a problem, we do some observations, we check what has been done in the past, we discuss between each other, and then we have fun trying to brainstorm a bit, like what can we do in order to address this problem. Then we work on the solution, we do some prototypes, then we break it. We try the best as we can to make it fail, and then we fix it. And then when this is working, we start thinking, okay, let's use this in order to do research. And then we evaluate the system, we write it up, and then we promote the system. So here's a very example. This is actually from home. I had a problem at my parents' house. Every time I got home, the mail would either been taken out of the mailbox or not. So I was tired of always opening the mailbox and always finding it empty, or I didn't know if anyone has arrived before me home. So what I decided to do is I just took an Arduino, I put a sensor in there, and I put it inside the box. And all it did was it would actually send me an email every time I got physical mail. And it would actually send me an email every time someone took the mail off. So by the time I got home, I already knew, okay, my mom has arrived at this time, or the mailman came at this time. Actually, what happened to me is that after this, I actually realized what the mailman was doing in Canisia. He was actually hoarding all the mail to Fridays. Every Friday, he would just dump all the mail. He would never come on the other days. And that was really strange. And then, basically, I just realized that we actually just get so little mail throughout the week that he just decided, okay, I'll just bring everything on Friday, and then it's okay. But anyway, this actually opened my eyes a bit to see, okay, I can actually look at what other people do just using sensors. And so this was kind of like an interesting project for me. As a side thing, I actually did this while I was here in Madeira. There's some state machine in there, so new mail. I got a notification by email. If someone opens the door, it resets the status and it sends a notification on the email that was collected. If the door was not open, I would not get anything, so I would still have the previous notification that there's new mail. And if there's no mail, I would open the door, nothing would happen. Okay. So also in all, thinking about the context, we have these things called public displays, and these are interactive displays that people can use throughout the city. We have about 12 of these throughout the city, and we use these as a gateway to communicate with the citizens of the city. We provide them with questionnaires, information about the traffic, bus schedules, stuff like this. Anyone can go there and use this. The problem is, we design for these things, thinking, oh, this is great. Everyone's going to love this service and everything. And then we get things like this. Okay, good luck getting to the public display. Yeah, so this is winter in Finland. And I can guarantee you, you will not want to take your gloves off when it's -30. So, yeah. So these work fine during the summer. The problem is we also live in Finland, so we get 24 hours of sunlight. There's no sunset. Which means that that material also reflects you like a mirror. So that means if you want to use that thing, you need to do this kind of thing, and then you can use it. So that means backgrounds should be black with white fonts, and then you can read it in the daylight. So like I said, technology, context. You always need to think about where your technology is going to be used, and how you design whatever you're building in order to fit in the context in which the user is going to be. Okay. Other things we have available to us in terms of technology is we have this widespread Wi-Fi and Bluetooth network that we can use to monitor. We provide free access to internet to everyone for free. It's open network. But we also use this in order to look at mobility. So we look at where do people go on a Friday night? Where's the most popular bar? And things like this. So we actually built a platform to look at urban patterns. So things like favorite places to eat, best restaurants to go, and all of this is done without just using the Wi-Fi. So as you connect, people connect and move around the city, we can know, okay, this person is here, this person is there, is spending some time eating there and going there. And this is information that anyone in the city can actually see from these public displays. Okay? The other thing that we have is traffic sensors everywhere in all the roads. And we do this in order to know how the driving conditions are, especially in the winter. So if you have a sudden drop of temperature, the roads get really icy. And so basically we look at things like slippery conditions, amount of snow on top of the road, things like this. And this is throughout the whole city. And this led to a collaboration that we did with the Traffic Control Center in our city. And basically we built for them a dashboard where you could actually see which intersection is the most busy right now. They actually use the same platform to also give green light to emergency response, like firefighters and ambulances. And they also can see like how much decay has happened in the road based on the traffic, amount of traffic that the road has happened. Should they go there and fix the road and things like this. The other thing is that we do a lot in Finland is we bike a lot. So we decided, okay, why should just cars have priority in the green light? And why not cyclists? So what we decided was, okay, if you're biking, you probably don't want to have to stop and then press the button to get the green light. So what we decided to do was we built an app that basically reports your location to the traffic center, and the traffic center can see, okay, you're going towards this intersection, this is the road you're making, we predict that with 90% accuracy, we're going to push the green light before you even reach there. And so we maximize the chances of you not having to stop at all, so you just keep biking. We look at are you walking or biking, the location semantics, so that means that not every location is actually treated equally. Some parts there's more cars than bikers and vice versa. So that plays a role in the weighting how important is a cyclist versus a car. And then flock dynamics. So are you alone or do you come with the multiple people around you? So we also take that into account. So we don't do this just with the phone, but we also use the radars. So every intersection also has radars. It can detect how many people are actually waiting. What else? So the other challenge we have is getting the user's attention. So we have a lot of these wearables nowadays, like the picture shows in there. You have your phone, you have your wearables, you have your smartwatch. All of these are competing for your attention. And so that means that if you need to keep someone informed about your system, you need to kind of compete with everything else that he has running on his phone, like Facebook or WhatsApp or whatever. And so how do you get the user's attention towards what you want to provide to them in terms of a service? So that's another challenge we have to deal with, especially because of this. So people do a lot of stuff now with their phone that they couldn't do in the old days. So in the old days, you could just talk, text and calls, but now you can play games, you have social networks, you can chat, you can see videos, you can stream music, you can do so many things in there, which means that literally when you build something on your phone, you need to take into account that you're not alone. Probably they have some other app that will do exactly the same thing as you do, or not. So it depends. And then how do you make sure that your user will keep using your app for a long time? So this is one of the biggest challenges we have nowadays. So according to Gartner, by last year, more than 60% of teenagers will have or use a connected device, which means that the generation of today will be the generation of tomorrow. So that means that whatever we build today will likely be used by tomorrow's elderly. So that shows me this. So we had this pilot where we actually had some VR technology to show this old lady about how she could experience the city of Oulu using virtual reality. And she couldn't believe that she could actually be somewhere just like that. She actually thought that she was being tricked somehow. And it was quite interesting to see the woman's reaction to, oh, I'm now downtown. Oh, now I'm in the city center. Okay, what's happening here? So what this means is that whatever you build today, you need to think about how is it going to be used in the future. Is it just for the next 5 years, or is it for the next 30 years? Okay. So my research, primarily during my PhD, has been focused on smartphones. My idea was that, okay, a smartphone is a very personal device. That means that it's always on, as long as there's battery in there, and it's always with the user. So that means that it's a very good proxy to interact with users, anywhere they are. And then the fact that you can actually build mobile applications on top of that, and you can use the sensors to generate context based on the raw data that you have on the sensors. You can actually provide information to the user wherever he goes. So this was, for me, during my PhD, was how can I use these devices in order to provide technology or systems that would improve people's lives. And for that, I built a platform that is in use by many people nowadays. And all it does is it takes the raw data and from the sensors, from hardware, software, and also human input, because there are things that are really difficult to sense with raw sensors, but you can just simply ask someone. So for example, how many people are sitting in here? If you try to detect that using Bluetooth, you will have a really hard time, but if you ask someone, can you count how many people are here? They can do that in 5 minutes and give you an answer. So we use all of these to collect data, and then we perform analysis, and then we can create these plugins, which are literally applications that use the same platform. We can conduct user studies and build applications for anyone. So this also focuses on developers. So you don't need to start from scratch. So if you want to do a step counter, you don't need to do that yourself. It's already done. So here's some example of the human-based sensing. So for example, I can ask an open-ended question. I can ask you to choose between a limited amount of options, multiple choice, ask you to be more specific on a specific choice, Likert scales, normal scales, dates and times, ham, which is measuring mood, numbers, and many others. So in terms of a platform, it's a platform that is geared for researchers, but it also can be used by developers. And it gives you total control over your study. So if you're doing large-scale distributed studies or even personal, you can use this platform for free. It's open source. Everything's open source, including the server side, which is great because from the moment I open sourced the whole thing, the whole platform exploded. So you can host your own database. You can run multiple studies simultaneously. You can create your own plugins if you want, specific for a study or share with everyone. You can enroll participants using a QR code or a URL. You can collaborate with other people. And so this is what I was saying, that you can't do things alone. And so if you want to share data with someone else that is located on the other side of the world, you probably would want to have some way to share the data with them. So the way we provide that, they can monitor how the study is going, so they can see how much data has been coming, which participants are actually still collecting the data. You can do A/B testing, so you can label a set of participants and have 2 different conditions, so you can do this kind of thing. You can remotely design and trigger these questionnaires that I showed you before, and also request the data to sync or even reset. So a major problem sometimes in the study is that, you realize, I forgot to activate this sensor. Maybe I should restart the study. Just that I have 1,000 participants. So now you can do that. So you can just reset the whole thing. Everyone who has been signed up will just reset and restart the study again. So you don't need to do this kind of things. So if you want more details about the architecture, and I have to thank Professor Lionel for that. Lionel there was my master thesis supervisor, and he actually taught me how to think about a problem in pieces and not everything at once. I can give you a very brief historical snippet. My first week during my master's, I implemented the thing I had to do for my master's in a week. And Professor Lionel went there and he was like, it's cute, but it's not good enough. And he deleted everything. Start over. So anyway, the platform is modular. And in the sense that you have the client side and you have the server side, both sides, you can add additional functionality that doesn't exist by default. And like I said, everything's open source, so you can actually take it, change it, modify it for your needs. Okay? And this is how it looks like a year ago. We actually have recently updated this on the Play Store last week. Actually, it looks a bit different. I will show you how it looks in a brief moment. And so basically, you have the main client where you can activate what you want to collect data from. You can add plugins which are, they just take the raw data and transform it in a way that you understand. So for example, the weather conditions, step counting, ESMs, how much you use your phone. So you can see an example of that over there. And all of that data is collected from your phone. And like I said, it's open to everyone. If you want to install it, it's actually on the Play Store, both on the Googles and Apples. So we also have an iOS version of it. Okay, so where did this whole thing start? It started with this. So the challenge of impact. So I am an academic, and that means that for me to be successful in what I do, I need to somehow have an impact in society. And that is shown based on publications, based on PhD students that graduate, or master students, or just affecting people's lives, okay? And so what happens with impact is that when you start having impact, it goes like a domino. Things start to pile up, and then all of a sudden you have things happening that sometimes are out of your hands. And this means that by that time, if you don't have a team with you or a set of people to help you, it will be really difficult to keep up with everything that's going on. So the framework that I was talking about started here. This was a long time ago, 2010, when I graduated from my master's in HEI. And it started with a very simple problem. Help people who are mobile sales people to know who the customers are, how important they are, and remember what has happened while they were busy in the meeting. Very simple topic, but it actually allowed me to start thinking about how can I use smartphones to provide this kind of information. But there's no audio coming from there. Alright, so as you can see, this is when I made the switch between building something to actually building something from first the requirements and then the software. So on this project, a lot of the focus was how do I make life easier for our customer. So our customer was Novabuzz, and they had these called Road Warriors, which are basically their sales force. And when we were approached, they initially wanted a desk phone that would actually tell them, like, this person, important person is calling. That was their initial idea. And then we decided, okay, that's not going to work. No one uses your desk phone anymore. If people are in the car, they're driving all over the place, they have meetings everywhere. So maybe we just do an application that runs on your phone, is integrated with your phone, and manages your contacts like that. So this was when I started to think about, okay, how can I use Android as a platform to do research, collecting data, and use that in a meaningful way. So this is when I started doing my PhD. My first deployment was looking at how people charge their phones. 4,000 participants, and we look at 6 months of data of people, how they charge, when they charge, how long they charge, things like this. This was my first publication ever, was this. And after that, we looked at how often people actually spend close to their phone, because the idea was, can I use the phone really as a proxy to a person? And looking into this, we could also think about how likely is it for someone to see what I want them to interact with if they're not close to their phone. It's actually about 50% of the time at your arm's reach. So actually my phone right now is here. Yeah, it's here. But when I'm at home, it's actually somewhere in the counter or something like that. When I get home, I just put it there. And if it rings, I go there and pick it up, but normally it's not with me. It's 89% on the same room as you're in, most of the times, but that depends on the time of the day, depends on the person, so it changes a lot. The other thing was also, again, looking at battery stuff. We tried to see how can I make you aware of applications that are running on your phone and making so that you would save battery life by killing them in the background. We would do estimation of how much time you have left based on the current battery you have and the current drain your phone currently has, given all the apps you have. So that was another publication. Another one was looking at how people use applications. So one thing that we actually found was really strange is that people actually use applications for very brief periods of time, which goes against to everything we thought before. Before we thought, okay, we make an application, people will use it. We really didn't think about like how much time do they actually spend on your application. And what we actually found is that most of them actually spend about 15 seconds. That's it. That's how much you get of the user's attention in your app, and on average. And what we actually started to think about was, okay, which applications actually are designed with this in mind? So if you think about Facebook, what is it about Facebook that you see first when you open the app? The bar on the top. You see the notifications, you see the red dot there that shows you, okay, you have this many things here pending for you. And that is very clever design. And so if you have an app that you want people to quickly glance, okay, do I have something or not, and leave. So the same thing for a Gmail. You go to Gmail, the unread messages go always on the top. You always see them first, and then you have everything else. Same thing for Twitter. So when you design an application, you need to think about what is it that I can give you that will make you satisfied with my app in 15 seconds. So this also depends on where you are. Are you around someone else, and the time of the day. So what we notice is that at the end of the day, people tend to spend more time. And that's kind of to be expected. But if you're on the go, and if you're on the bus or something like that, you might check your Facebook, you look at it, you change, you go to your play music or whatever. So you don't spend too much time looking at your screen because, I mean, you're in the bus, you might get car sick or something like that. So that also depends. And if you're around someone, you probably don't want to be spending time looking at your phone. Yeah, that was great. And you continue there. And you're having a drink with your friends. So that was another one. And this is how it looked like in terms of the aware running on the phone. As soon as you did micro usage, so you used an app for less than 15 seconds, I would ask you, like, why did you use this app? Where are you, and are you alone or not? So we collected this data on the fly. This was so brief, and it happened so many times that we actually had to restrict it to only do it once every hour. Because people do this all the time. And so if we ask this question all the time, they will just quit the study because it will keep asking you this every single time. The other thing we did was actually try to explore other ways of communication using your smartphone. This is another project that we actually use the magnetic fields to communicate between two devices. So it's not very fast. It's only about 40 bits per second. Very short ranged, so it's almost like NFC. But this works on any phone that has a compass. So this means even for phones that don't have NFC, this would work to send data between a terminal and their phone. The technology for this and the algorithm for this actually got sold to Tokyo's metro system. And they're using this to check entry gates into the subway. So people that have very old-fashioned phones, feature phones, what they call, they just put them there, it identifies the phone based on the magnetic fields, and then the person just gets in. So this is one of the outputs we had from our research group. So there's an example here. So it's decoding like a string of text using magnetic fields. And then there's another case here that it actually plays music. Of course, it's not your MP3, but it still plays some tunes in there. The other project that I worked on, and this was for industry, was with Halcyon. And they had a problem which was to inform parents where their kids are at all times. But they wanted to do that without using smartphones. So their premise was, I don't want my kid to spend more time looking at the screen than what it needs to. And so we created a solution that has partially smartphone, partially a phone for the kid that works well. So you could create geofences of known locations for the pupil, and then as he went through the road or the path to school, we could see where they are at any moment. We could define areas that they can't go, like a forest or a neighborhood, a tough neighborhood, and the mom could actually get notification of that okay, she's approaching an area that she shouldn't be wandering around. And the device itself is waterproof, and the only thing it does is have a button. And the kid, when he wants to talk with the mom, she just presses the button, the mom can call her. She can't hang up the call. The only person who can hang up the call is the mom or the parent. And the dad, in this case, can also see what's going on. So in a way, you can see this is kind of a fusion of what I did before with this mobile, the road warriors and families, like trying to help them coordinate. What time did they get to school? Is everything okay? And things like this. You can see some similarity in the presentation. So we actually recently have evolved this beyond this. So we had some families who actually they don't have kids anymore. They have teenagers. So how do you bring this product that they have to the next stage? And so we actually had another project called Family, which is kind of going ahead with this, and it's mostly meant for families to coordinate family life in general. idea here was that if you have things to do, you might want to know where your wife is, to coordinate. Did you leave work already? Did you go to the groceries? Did you go pick up your kids? So we had all of this. You could schedule stuff, like things like pick up John from soccer practice, go to the groceries, I don't know, visit grandma, things like this. It also has the activity recognition in there, so you will know if someone is driving, is someone biking, is someone taking the bus, all of these. You can define personal places. So, for example, I'm at the gym right now, or I'm at the bar with my friends, or things like this. So you can define geofences, and your wife will know that, or your husband. We also had this encouraging family time. So if you're close to each other, we also monitored how much time did they spend together. So we looked at, it's funny, before I did this application, I only had on average about 2 hours of family time with my wife, and we changed that recently, since then, and now we make an effort to go exercise together at the end of the day. But yeah, sometimes having this data actually slaps you in the face and see, okay, you're not spending that much time at home. So this is another project that I worked with a different company. So they had a problem, which is indoor location. So GPS doesn't work well indoors. And so I worked with Indoor Atlas to make their algorithms more power efficient due to my research before in power savings and also sampling and sensors. And the idea was to make the SDK as power efficient as possible. And I worked there for 3 months. So for those who are not familiar,
and where we want to go, but just don't know how to get there. The compass is one of the greatest and most reliable navigation tools of all time, and has been used by great explorers throughout the centuries.
Portugal!
We decided to bring this trusted tool into the 21st century as an indoor positioning solution that's based on the anomalies found in magnetic fields, that universal, fundamental force of nature. Modern buildings all have a unique magnetic landscape, produced by the natural geomagnetic fields that interact with their steel structures. By using your phone's built-in digital compass, our patented solution can use this magnetic landscape as a map for pinpointing locations indoors. Our cloud-based, software-only solution makes indoor positioning ubiquitous and available for everyone, opening a range of possibilities for app developers around the world. They can build location-based applications for a variety of uses, such as social navigation, search, safety, gaming, and advertising. Indoor Atlas's game-changing indoor positioning service is now available for a range of iOS and Android devices and open to developers worldwide. Free your imagination and build your greatest location-based app today. Try it for free. Sign up at indooratlas.com.
Alright, so that's also open, so you can use it for your own purposes. And this uses magnetic fields, also uses Wi-Fi triangulation and Bluetooth beacons to pinpoint where you are. And it's also accurate up to 20 centimeters indoors, which is quite nice. What else? So after this, I started doing more research related to health and mobile health. And one of the things we've been looking at is nomophobia. So the fear that people have of not having their phone available to them. So things like running out of battery, not having network coverage. So one of the things that we are not sure is how do you measure this? So you wouldn't want to ask someone constantly, like, are you afraid right now? Are you afraid right now? People might get a bit frustrated with that. The other thing is it self-inflicted or induced or externally? So it might be that someone feels more anxious when their phone dies because they can't get a call from their boss. Or they can't be reached by their wife or something like that. So what is it? Or is it both? If it's self, so what can we do to minimize this kind of discomfort? If it's externally, who or what triggers it? Is it really a problem? So this is also the thing. Like, we are increasingly connected, so I think it's normal for someone to feel more anxious when their phone dies. And then what can we do to minimize this effect? The other thing was looking at mood, measuring mood. So we're working both with MIT and University of Bonn, looking at how can we use physiological and also patterns on how you use your phone to infer, are you angry, are you anxious, are you stressed, and all of these things. Of course, there's still some open questions in there. So what is the ground truth on the measurement of mood? How does it change? And what are the external factors? Do applications actually affect you? So one thing that comes to mind is a research that was recently published by Facebook, where they actually confessed that they were affecting how the news feed affected people's perception of their feed. So they would show you more bad stuff and see how you would react to that. Or they would just show you happy stuff, and then what would happen to you, like what happened to your posts. And then I guess the biggest challenge is how do you measure mood without affecting it? Because the thing is, from the moment you realize that there's someone is measuring how you feel, you change how you feel, right? That's a really tricky one. The other thing is looking at asthma and the effects of weather, air quality, the amount of exercise you do, and symptoms you have, how they change throughout the year, through the seasons, and does really exercising affect your asthma symptoms? Does it make you feel better? Does it make you feel worse? Does it depend on where you go to exercise? Things like this. We are doing this with the World Health Organization and the Center of Environmental Respiratory Health in Finland. And again, we are using the ESMs to measure these things, like asking you symptoms. How do you feel today? We notice you've been exercising. How do you feel? I have a runny nose. I have cough. Things like this. I have chest pain. And the doctors then use this information to figure out, okay, what is wrong, how we can improve your treatment, how often you should exercise, where you should exercise. The air quality of where you go running is actually really poor. When you go running, you maybe should go in the morning instead of the evening and things like this. The other thing is measuring Parkinson's. So we're using smartwatches, and the idea was that medication for Parkinson's changes or affects people differently based on your body, based on what you eat, based on the exercise you do. And the thing is, for some people, medication is okay for 6-7 hours, where they don't shake for the time, but for other people, it might cut off around 4 hours or even 2 hours, depending on what they do. And the idea here was to use the smartwatch in order to detect microtremors. So the person would be reminded to take the medication even before she realizes that she's starting to exhibit the symptoms that the medication is starting to wear off. And more recently, we're doing the symptom progression and monitoring. So we're using the smartwatch and how when people use their phone in order to notice, okay, you are starting to shake more than what you used to a month ago. So maybe you should increase the dosage of your medication. Another one is looking at cancer treatment. So the other thing is that right now the cancer treatment process is that you have a very generic cocktail of chemicals that is the same for everyone, but that affects you in different ways. And what they're trying to do in the US, at the University of Pittsburgh Medical Center, is to create a personalized treatment based on the symptoms you report on the treatment you're making. So basically, twice a day, we ask them to report like pain, nausea, sleep disturbance, feeling disconnected. So also looking at sociological and physiological measurements like back pain and things like this. And the idea is that every 2 weeks, they would tweak a bit the chemical. So they would remove this one and see what happens for the next 2 weeks. And then they could keep doing this so that you still have progression on the treatment, your treatment is still effective, but you have the least pain as possible. The other one is looking at sedentarism and basically looking at people's motivation to exercise. In the US, it's a big problem, and we actually have integrated with Fitbit and Jawbone. We have plugins for that, and the idea is that we would collect data on how much exercise you do, when you do it, your heart rate throughout the day, and the idea is to collect data on why do you go exercise, why you didn't go exercise, when do you go exercise, and we have 2 projects, one of them also with the medical center in Pittsburgh, but also with Georgia Tech, MIT, Cornell, Dartmouth, the universities, where they're actually looking at this from the perspective of students. And so they're looking at how much what they do outside of school affects their performance at school. So we're also looking at this. And recently, I got a project where we're actually using everything we've done so far, from applications we built and bring that to IoT and looking at elderly care. And the idea is that we will make an application that will make taking care of someone in a care center easier. And the idea is to make sure that people are feeling okay during the time that they are on the elderly care centers, even when they live at home alone. So to help families to know that everything's okay, my parent is not spending 10 hours watching TV, when was the last time I went there to visit them, things like this. And the idea is that by the end of the project, we will have a platform similar to Aware, but in this case, geared to do IoT indoors. And it's actually right now being piloted in elderly care in Finland, and we're going to expand that to the whole country. So that's what's coming right now. This is how the application looks like. It's in Finnish. Don't worry, I can translate for you. So this is the main view for the... yes, I do speak Finnish. So this is the main interface for the caregivers and also families. So they can see like your body temperature, when was the last time you went to the bathroom, when was the last time you went there to talk with them. This is medication needs, so how many times per day, what was the last comments from the doctors, allergies they might have, who are your family members, who's the most important person for you will be on the top. And this is things about their personality, so things like when was the person born, who was he married with, things that he likes to talk about and things that he doesn't like. And so basically with this tool, the caregivers can quickly get to know someone in the elderly care, especially that they have a lot of mobility between people who come work and leave from the services. And this gives them information that would be really difficult to get nowadays. So nowadays, the current system, they need to go to a computer somewhere, located in a different room to get this information, then they come back again to the person. And we have this application that runs on their phone. And all of these measurements come from sensors that we have put on the bathroom, on the person's bed. So the person itself doesn't have any sensors, okay? So with the exception of this one, but this one comes from this alert band that they have, that they press a button to call for help. That also measures the body temperature, so we have that. And because that also has Bluetooth, we can actually detect the distance between the phone of the caregiver and the person. So we can see, okay, when was the last time you actually went and checked on them. So we also, with this, we can also look at when you're sleeping. So your body temperature actually drops when you sleep. So we can know, like, okay, this person is currently sleeping or not. And of course, if the person dies, we can also know that. Which is the sad reality, but it's also a tool that actually helps the nurses to know, okay, there's something going on. The person, so we also have, we don't see it here, but we also have activity monitor. So we also have levels of threshold of movement. So if someone is having a seizure, we will know that. So things like this. And basically that's it. So that's everything I've been doing. And I'm now open to questions you might have.